Welcome back to Future News. As always, you'll find an article link corroborating this historical endeavour in the description below. Now then, deep beneath the French-Swiss border, the Large Hadron Collider. Our planet's most powerful time machine awakens once more. This 27-kilometre ring of superconducting magnets has given us the Higgs boson particle, probing the universe's deepest mysteries. But today, July 24th, 2025, it's embarking on a new journey, smashing together atoms of oxygen for the first time. Oxygen, so familiar, yet never before accelerated to near light speed and collided in this way. Scientists at CERN hope to recreate the universe's first moments using a building block of life itself. By colliding oxygen, we step into a middle ground between simple proton collisions and massive lead smash-ups, exploring uncharted territory. The goal to create and study Quark-Gluon plasma, the primordial soup that existed just after the Big Bang. This experiment could reveal how our universe emerged from that fiery beginning. The air crackles with anticipation as a new chapter in our cosmic story begins. The LHC is a racetrack for particles, accelerating them to nearly light speed and smashing them together to mimic the Big Bang. Until now, it's collided protons, simple, clean, and lead nuclei, massive, chaotic. But there's a gap. What happens in between? Enter oxygen with its 8 protons and 8 neutrons, a perfect middleweight. By colliding oxygen, scientists hope to pinpoint when the universe's primordial soup, the Quark-Gluon plasma, first forms. It's a question of scale. How big must a collision be to create this exotic state? As Ricardo Longo from Atlas says, these collisions connect the dots between the smallest and largest experiments. Oxygen lets us study the transition from simple to complex, from puddle to ocean. For the first time, we'll see what happens in this unexplored middle ground. It's a true scientific frontier. 13.8 billion years ago, the universe was a seething soup of quarks and gluons. No protons, no neutrons, just pure chaos. This Quark-Gluon plasma, or QGP, is the most perfect liquid ever known, flowing with almost no friction. The LHC's heavy ion collisions recreate this state for a fleeting instant, letting us study the strong nuclear force, the glue of the universe. Lead collisions showed us QGP behaves like a liquid, not a gas, a surprise to physicists. Now, oxygen collisions let us test if this perfect flow appears in smaller systems. Does a tiny droplet of QGP still act collectively, or do the rules change? It's like testing the universe's recipe in a medium-sized pot. The answers will reveal how the early universe transformed into the matter we see today. It's a fundamental quest to understand our cosmic origins. Scientists will hunt for jet quenching, a telltale sign of Quark-Gluon plasma. In lead collisions, high-energy jets lose energy in the plasma, like bullets through water. But in proton collisions, jets fly through untouched. Will oxygen collisions be big enough for jet quenching to appear? Pinpointing this threshold is key. Next, they'll look for collective flow, particles moving together, revealing the liquid nature of QGP. Measuring this in oxygen will show how the strong force's fluidity emerges as system size grows. Finally, the experiment will probe the shape of the oxygen nucleus itself. Soon, the LHC will collide neon, letting scientists compare how different nuclear shapes affect the plasma. Back-to-back runs with oxygen and neon will unlock new insights into the building blocks of matter. Each collision brings us closer to understanding the universe's most extreme states. Colliding oxygen isn't easy. New technical challenges arise, like the transmutation effect, where unwanted particles pollute the beam. LHC operators may need to dump and refresh the beam to keep data clean, adding suspense to every run. Overcoming these hurdles is part of the adventure, showcasing the dedication of thousands at CERN. Despite the risks, excitement fills the air. This is what discovery feels like. The data from these collisions will be studied for years, filling a crucial gap in our understanding of matter under extreme conditions. By smashing together a piece of the air we breathe, we reach back to the dawn of time. The results may confirm our theories or force us to rethink everything. The beast has awakened and a new horizon awaits. Don't forget to like, subscribe and share this video with a friend. Thank you very much for watching. Stay tuned.